right, so let's finish off section 3.7, page 189, example number 4. You can see example 3 here that was the last one that we had worked together. So let's pick up with example 4. On page 189, they tell me that two curves are called orthogonal if at each point of intersection their tangent lines are perpendicular. In the next example, we'll use implicit differentiation to show that two families of curves are orthogonal trajectories of each other. That is, every curve in one family is orthogonal to every curve in the other family. All right, now we saw orthogonal last year with vectors, right? Basically meant two things that come together at a 90-degree angle, very similar to the idea of perpendicular to each other. So they tell me, for example 4, that I have xy is equal to a constant, and I have x squared minus y squared is equal to a constant. And they ask me to find those derivatives implicitly, all right? So if we come over here for xy is equal to c, I have a product, right? So I'm going to have to do first times derivative of second. And when I do the derivative of y, the derivative of y is going to give me 1 dy dx. Then plus second times derivative of first. So second is y, and the derivative of x is just 1. And then on the right-hand side, the derivative of a constant is 0. So we've done our implicit differentiation. Now we want to get dy dx on one side by itself. So I could subtract my y to the other side and then divide by x. All right, let's do our implicit differentiation on our second equation. So if we go through and say the derivative of x squared is 2x, and the derivative of y squared is 2y, and we have to leave the dy dx in there because y was not in terms of x. And again, the derivative of a constant is 0. So let's solve for dy dx. So let's subtract the 2x over to the other side. And then to get that dy dx by itself, we could divide by negative 2y. And our negative 2's would drop each other out, so we're left with x over y. Now, they wanted to show that these two curves were orthogonal because at every point of intersection, their tangent lines are perpendicular. What do we know about perpendicular lines? Their slopes are negative reciprocals. So if they want to show that at any point of intersection their tangent lines are perpendicular, slope of a tangent line is derivative, right? So all we need to do is show that their derivatives are negative reciprocals of each other. And that's exactly what just happened right here. This derivative, negative y over x, is the negative reciprocal of this derivative, x over y. So since those two are negative reciprocals of each other, any point that I would put in there, those points of intersection, would be perpendicular, meaning that I have orthogonal trajectories. Okay? All right, so just one more example to give us some extra practice on this idea of implicit differentiation. Our goal is really just to have a couple more of these problems to practice on to kind of cement this concept down.